Hello everyone. Before you even tackle this video, you need to make sure that you have watched the percent concentrations lecture video and the molarity and osmolarity lecture video. Otherwise, this is going to be a bunch of gibberish for you. In this lecture video, I'm going to be concentrating on how you actually can go from one unit concentration to a different. So how do you go from percent volume to percent mass volume, or percent mass volume to molarity, and vice versa. Okay, and again, there's a reason why this is, so we might as well tackle it. And one of the requirements for this is you need to understand what those different concentration units are before you even proceed further. So here we have a solution that is shown as percent mass volume, and what we're doing is we're trying to change this into molarity, right? So the first thing that you have to understand again about unit concentration, especially percent concentrations, is that if you see 5%, that means it's 5 of the solute over 100 mils of the solution. Now it could be 100 grams too, but all you have to do is find out what does these units. What does M mean? M means grams, V means milliliters. So 5% mass volume can actually be expressed as 5 grams of sodium chloride over 100 mils of solution. If you understand that, converting it to molarity is actually quite a straightforward matter. So again, what's more emphasis here? 5% mass volume. So the first thing is we need to change this grams, this 5 grams of sodium chloride, into moles of sodium chloride. Why? Because molarity is moles over liter. Okay, so we're trying to do this grams into moles, and again we use the molar mass of sodium chloride, which is 58.44. Again, you go to the table of elements and find the atomic weight of one sodium and one chlorine and add them together. This is going to be how many moles you have. Now moles is done. Now we need to have the liters. Guess where the liters come from? That liter is going to come from this 100 mils of solution, but we need to convert it first into liters. And again, this is from metric system conversions. 100 mils times 1 divided by 1000, which is 0.1 liters. And then it's a straightforward, take this moles divided by that liter, which gives us 0.86 molar in this case. Okay, so that is how you convert from a percent mass volume to molarity. And again, the key to this one is understanding what is this unit concentration mean? What does that mean? What does that mean? Okay, so before you even proceed further, you need to be familiar with those unit concentrations. Okay, another example. What is the molarity of a 12% volume lithium chloride solution? So this means to say that it's 12 mils of lithium chloride over, what is the denominator for 80%? 100 mils of solution. And I'm giving you the density of lithium chloride. Why? Because you will use it, right? Again, 12 mils over 100 mils. Now, why am I giving you density here? Now, molarity, again, is moles over liter. Moles come from grams. Right now, we do not have the grams of solute. What we have is we have milliliters of solute. So the way that we go from milliliters of solute to grams of solute is by using density. Okay, so here we go, 12 mils lithium chloride times 2.068 grams over 1 mil. The mils cancel. We have grams of lithium chloride. So from 12 mils of lithium chloride, we now have 24.8 grams of lithium chloride. Here's another note as well. If you have an ionic solid, the mass of the ionic solid is going to be greater than the actual volume of the ionic solid. Okay? And then the next step is we're going to go from grams into moles. And again, this is using the molar mass of lithium chloride. You go to the table of elements again, find the mass of 1 lithium, 1 chloride, do the division, 0.585. Now remember, we're trying to go to molarity here, which is moles over liter. We already have moles. What are we missing? We're missing liters, and it's going to be similar. It's going to be similar to this math here. Okay, so 100 mils divided by 1000 mils, that gives you 0.1 liters. do the division, gives you 5.85 molars of lithium chloride, right? It's a little bit more loaded, but again, understand that the number on top is always the solute. The number on the bottom is always the volume of the solution, or the gram solution, whatever is indicated. And if it's a percent, the number on the bottom is always 100 mils. And if I give you density, you need to understand that you will have to use that density to convert something, right? Here we have another conversion between concentration units. So this is what is the percent vol. So now we're going backwards. We're going from molar to percent vol. And again, understand that molar is moles over liter. Okay. So first thing is that it's expressed as 2 moles over 1,000 mils, because a liter is also the same as 1,000 milliliters. So the next step is now we got to convert this 2 moles into grams, because we're trying to go to volume. And again, volume is actually just mils of solute over mils of solution times 100. I hope you all remembered that first. And I hope that you have your notes in front of you as you do these problems. So we multiply 2 moles times the molar mass of sodium bromide. That gives us 210 grams sodium bromide. Now remember, we need mils of solute on top. Is this mils? No. We need to convert this grams of sodium bromide to mils using, take a wild guess, the density. This is why I give you the density. Here we go. 210 grams is equal to 65 mils. Now we have mil of solute. Right? And now we take the mils of solute divided by the total volume of the solution, which is 1,000 mils. You cannot use 1 liter, folks. Right? You have to make sure that the 1 liter is actually converted into mils. It has to be the same units, or gram over mil. And this is why this is 6.5% sodium bromide. Okay, I hope that makes sense. All right, so the next part now is application for concentration units. So we've done, why did we do all of this percent concentrations, molarity, osmolarity? It's because we're trying to apply it to the colligative properties. What happens to the boiling point? Right? What happens to the freezing point? What happens to osmolarity? What happens to the osmotic pressure? So here you're trying to compare which one of this is going to have a higher boiling point. And here's the key. Whichever one has more solute in it will have a higher boiling point. So you have two different ways, two possible ways that you can do this. You can actually go from molarity to gram volume, because you must compare the same units. This unit is different. This is molarity, this is percent gram volume. Or you can go from percent sodium chloride into molarity, because otherwise it's not a true comparison. Okay, so for my case I did molarity. Okay, so I am gonna convert, again, 1% sodium chloride means 1 gram solute over 100 mils of solution. Convert this grams into moles by using the molar mass. Convert this volume into liters by using metric conversion. We do the division to get molarity, 0.02 divided by 0.1 liter. It's 0.2 molar. So here's the deal. Now we're going to compare. So 1% sodium chloride is actually 0.2 molar. Which one has more solute in it? This one. Therefore, okay, right? So this one is bigger. This one has more. So therefore, this is going to boil, will have a higher boiling point. And similarly speaking, will actually have a lower freezing point. Right? So that is the effect of having more solute. And again, The reason why it said colligative properties is because the properties of boiling point, freezing point, and osmotic pressure is dependent upon how much solute is actually in the solution. So the more solute you have, the more it affects the boiling point and the freezing point. The less solute you have, the less it will affect the boiling point and freezing point. Okay? Another example. All right? Now this is about osmotic pressure in this case. So again, I give you two different concentration units, but not too bad. This is percent volume. This is percent gram volume. Again, we need to change one into the other or vice versa. Now, in order for this volume to change into grams, or in order for this gram to change into volume, regardless of where you're going, you need the density. All right? So what I have selected is I selected to change the mils of sodium chloride in the percent volume into grams of sodium chloride. So I did 2% volume is 2 mils sodium chloride, 2 mils of the solute over 100 mils of solution. All right, and we're going to convert this 2 mils into grams using the density. So this is where the density comes from. So in 2 mils of sodium chloride, there's actually 4 grams of sodium chloride. And then again, we take 4 grams over 100 mils. It's 4% sodium chloride. So now, let's look at this. Now we're going to compare two similar concentration units. So this is 4% gram volume. Sorry about that. This is 2% gram volume. Which one has more? This one. Right? So therefore this, which is this, will have a higher boiling point and lower freezing point, similar to the actual problem. Now there's another caveat here. If I separate these two solutions, 2% volume and 2% gram volume, which is shown by water permeable membrane, right? This is actually, again, make sure that you understand that this is actually 4% gram volume. All right, folks. If the remaining component is water, we need to understand that if it's 4% gram volume, this means it's going to be 96% water. But this means it's going to be 98% water. Okay? In terms of osmotic pressure, hypotonic, hypertonic, isotonic, we look at the percent concentration. This has more solute. This has less solute. This side that has more solute is called hypertonic. Hyper meaning higher, tonic meaning solute, like gin and tonic. This side is hypotonic. Guess where water is going to flow? Osmosis is always going to go from an area that has more water to an area that has less water. This is 96% water. This is 98% water. So therefore, water is going to go flow from, going to use blue for water, this side to that side. Okay? So again, the way that we've done this is, again, we cannot compare this to unit concentrations, just like we cannot compare this to unit concentrate because they're different units. So the solution to our problems, to this particular problems, is we need to make sure that one of them gets converted to the same unit similar to the other one. That way we have a true comparison as to which one is going to have more boiling point, freezing point, and osmotic pressure effects. Okay? We're going to talk about this in class.